Welcome you all. This is Sharan Arvind, the team lead. First of all, I would like to thank Cognizant for giving us the opportunity of conducting the Cognizant Nurture Hackathon, through which we could share our ideas and our own thoughts. So, firstly, let me introduce the team. We are a team of six from Sri Manakula Vainaga Engineering College, doing our fourth year in BTech of Artificial Intelligence and Data Science. And we have split ourselves into two teams, mainly AML development and web development. For AML development, we have Lekashree, Harshinee, and Sharan Arvind, myself. And in web development, we have Sharan J, Sanjay, and Pritika. I'll forward to Lekashree for the more. Thank you.
Hi, I am Lekashree. Let me start with the overview of the project. HLP is an AI driven system designed for hospitals to improve patient care by predicting health risks, diagnosing conditions early, and providing personalized interventions. It integrates with hospital operations, offering real time support to healthcare providers, enabling better decision making, and ultimately reducing human loss. What the project does: risk prediction accurately predict patient health risk, enabling early detection of critical conditions. Personalized care deliver customized healthcare recommendations and treatment plans based on patient data. Real time insights provides immediate analysis of patient information for doctors, enhancing clinical decision making. Data management simplifies the management of patient and doctor information, streamlining hospital operations. Next, I will pass on to Sharan J.
I'm Saranjay. I will explain the data flow and the overall structure of our product HLPS. Our product HLPS is a risk prediction product delivered to the hospital. Firstly, hospital admin should sign up the product so that we can store the data to our database which we have created using MongoDB. After sign up, hospital consists of dashboard and offers the dashboard is used to add the specialized doctor present in the hospital and the patient warden at the hospital. These details will be stored in the database of our respiratory this database. And say that there are two models, namely symptom model and the report model. The symptom model is like a convert. A symptom model is like a conversational model where the patient can enter their symptoms one by one. Using the symptoms, we can predict the risk of the patient, and the report will be generated which contains the predicted risk, predicted disease, and the doctor. The patient can visit for further clarification. Next, the report model. The patient can enter the report of the ECG or sugar test and the description of the report. The model will return the detailed report about the risk and the risk factor that causes the risk. Thank you. Now I will give to Arvind.
Hi, I'm Harshinee. In models, we have created three models. One is hospital side, patient side, and doctor side model. In hospital side, we have created hospital dashboard and offer model for the hospital side. And in patient model, we have created symptoms model, report model, PDF model, and offer model. Coming to doctor side, we have created real-time model, scriber model, PDF model, report model, and mortality model. I pass over to Sharan Arvind.
When it comes to the ML model, we have two main core models, are backbone models. Namely, we have the symptom model, we have the report model. So report model will be explained by Lekha in the following session, and I'm going to explain about the symptom model. So what the symptom model basically is, this is a model wherein which the user can come in, the patient can come in, he or she can give their symptoms, and with their symptoms, we're going to predict the risk and the problem for the particular patient. So how this model has been built is, we have created our own DB wherein we have created three tables, namely risk, problem, and then symptom. So the symptoms the patients are going to give in are going to be mapped with the symptoms in our table, and mapping these symptoms will give us the predicted problem, and while predicting the problem we can ultimately predict the risk according to it. In our DB we have around 20 sections of human risk, that is starting from cardiovascular, neurology, respiratory, kidney, cancer, and it goes on to 20, and we have 400 diseases that can be predicted out of it. So this is the DB we have created, and here we have it as a conversational bot wherein the user can come in, discuss with our bot, and he or she gives us the symptoms, and with the symptoms we are going to predict what risk and what problem the patient is having. Once we predict the risk and problem, we are going to give a planned report of what you have to do for this particular predicted risk and predicted problem, and we are also going to mention which doctor you have to go and visit for this particular risk. For instance, if the risk is being predicted as cardiovascular for a particular patient, in our at the start in our DB we said that we are going to have a specialization table where the hospital has to enter the specialized doctor in a particular section. So if the hospital has a cardiovascular specialist, they will be redirected to the particular doctor. So moving on, in our particular symptom model, what we have is correlated to the scriber model. Here, scribers are professionals. They listen to the conversational between the doctor and the patient, and listening to it what they can do is they can note down the symptoms. This is a professional that is being highly used in UK and US right now, and for them we have created a model which is a unique selling point of our product. And in this particular model, the scriber can come in, he or she can give the patient ID and doctor ID, then start giving the code directly. So we have unique code for each symptom. And listening to the conversation between the doctor and the patient, the scriber can enter the code. And what this particular model benefits is, with the scriber itself we can predict what the risk and problem a patient is having. So this can be also used by doctors in a virtual meeting with the patient, where they can note the symptoms here, and at the instance the meeting is over, we will be having a predicted risk and predicted problem for the particular patient. So this is one USP we have in our model. And to discuss technically about this, the symptom model and the scriber model are like a sibling model, because they are going to use the same MySQL database we have created. This model also can predict 20 human sections of risk and around 400 diseases, and it has its own symptom table. So everything here in our DB we have it as a code value pair. Each symptom is a value, and for each particular value we have a unique code, and with this unique code we can access the symptom. At the symptom model, we'll be using the value and predicting the risk and the problem. Here in the scriber model, we'll be evaluating the code, and using the code, we will evaluate the risk and problem for the particular patient. But both in scriber model and symptom model, we are going to predict what is the risk and what is the problem in a particular patient, give a personalized plan for it, and with this plan, in the scriber side, in the symptom side, we're also going to say which doctor the patient has to go and visit, and then the patient can go and visit the doctor.
Let me start with the report model. In report model, there are 5 main risk models. They are cardiovascular risk model, kidney risk model, neurology risk model, respiratory and cancer risk model. So first, the kidney risk model. The main purpose of this model is to detect the risk associated with the kidney disease, including chronic kidney disease, acute kidney injury, stone, cyst and tumor. For stone, cyst and tumor, we have trained the model using the image dataset, whereas for CKD and AKI, we have trained the model using the CSV file. Then cardiovascular risk model. The main purpose of this model is to identify the risk related to heart disease such as hypertension, coronary artery disease and heart failures. Then neurological risk model. The main focus on neurological disorders including stroke, Alzheimer, Parkinson disease and brain tumor. Here for brain tumor and Alzheimer we have used the image datasets, whereas for the stroke and Parkinson disease we have trained the model using the CSV file. Then the respiratory model. It focuses on the respiratory conditions like asthma, COPD and lung infections. And the last model is the cancer risk model. It identifies the potential cancer risk, focusing on common types like lung cancer, brain cancer, and kidney cancer. For lung cancer, we have trained the model using the CSV file, whereas for the kidney and brain cancer, we have trained the model using the image data sets the main focus of this model is to, when we upload a input, when we give the input to the model, it identifies the risk, the disease associated with it, and it could also able to identify the risk score for that particular input we have gave. And these values are passed as the parameters to the report generation model, in where the report will be generated based on these data. This report is generated using the Gemini model. Next, I will pass on to Harshinee.
Additionally, offer models are there in both hospital side and patient side. In hospital side, the purpose is to generate a personalized offer for patient based on their medical history, risk, and health current status. The feature is to analyze the patient data and create a tailored healthcare packages. The offer model in the patient side, the purpose is to display a personalized offer generated by the hospital's offer model. The feature is that it provides a personalized healthcare package tailored to the patient's healthcare needs, risk, and offering targets intervention and treatment. In doctor side, there are two models, real-time model and mortality model. In real-time model, the purpose is that it allows the doctor to enter the real-time data of the patient and receive an immediate output and prediction. The feature that it gives an instant analysis, provide a quick and accurate predictions based on the current data. It assists the doctor in making decisions during the consultant. In mortality model, the purpose is to predict the mortality risk of the patient based on the current health data and historical data trends. The feature is that the risk prediction, it calculates the probability of mortality, helps the doctor to personalize care and interventions. This includes the factors contributing to the risk and potential measures to mitigate it.
Architecture technology is used to implies your use of React, HTML, CSS, Bootstrap, and JavaScript for building a responsive and user-friendly interface. HTML and CSS describe how these are used for structuring and styling forms, report, and other UI components. Bootstrap are used to explain how we provide pre-built components, ensuring that UI is responsive across devices. JavaScript is used to highlight its role in dynamic behavior and data update, form submission, and interaction with backend APIs. And we have designed for the patient side models. For symptom model, shown the form when the patient inputs the symptoms. Explain how JavaScript sends the data to the backend from the analyze and dynamic display prediction. And the foot model demonstrates the report section where patient view details reproducing bootstrap cards and tables. PDF model explain how patient can upload the PDF and after analysis results are shown on the same pages. And in doctor side model, real-time model explain how doctor input real-time and get immediate prediction. For scriber model showcase the form where doctors enter scriber codes and view detailed risk reports. And for PDF, similar to the patient side PDF model, but doctor analyze patient documents. This is my part. The next part will be continued by Pritika.
Hi, I am Kritika and I have been responsible for the front-end development of a project. As you have heard, our risk prediction model integrates several key components like symptom analysis, report generation, and real-time data processing. My goal was to ensure that all these complex elements come together seamlessly in a user-friendly interface. It was important to us that healthcare providers can easily navigate the system, making it more powerful and accessible. In short, our model enhances the accuracy of medical diagnostics while also improving the overall user experience. By merging advanced machine learning with an intuitive, responsive design, we are helping to provide more and personalized care that is more timely and efficient. Thank you for your time and attention. We are really excited about the positive impact this model can bring to the healthcare. Thank you.